Today, we are going to do something really cool. We're going to build a game completely from scratch. We'll take a simple idea and walk through every single step to turn it into a real working prototype. So let's just dive right in. So let me ask you this. Have you ever had a great idea for a game, but you just stopped thinking, ugh, I don't know the first thing about code? Well, what if I told you it's way, way easier than you think? And you know what? We're going to prove it right here, right now. And this is the little powerhouse that's going to make it all happen. It's the BBC Microbit. It's this tiny pocket-sized computer that's got programmable buttons, a 5x5 grid of LED lights for a screen. It's just packed with potential. This little guy is going to be our console, our screen, and our controller all in one. So what are we actually building? We're starting with a classic, a simple guess the animal game. The idea is the microbit flashes an image of an animal on its little screen, and your friend has to guess what it is. It's simple, it's fun, and honestly, it's the perfect first project to get your feet wet. Okay, but hold on. Before we even think about writing a single line of Python, we need a plan. This is, and I'm not exaggerating, one of the most important steps. We're going to use something called pseudocode. The best way to think about it is like a recipe for a cake, you know? You write down all the steps before you start throwing flour and eggs in a bowl. That's all pseudocode is. It's our blueprint, but it's written in just plain, simple English. There's no complicated syntax to worry about. It's just the pure logic of what we want our program to do. And here it is. This is the whole blueprint for our game. See how simple it is? We start, we import the tools we need, and then we create two arrays. Just think of them as simple lists. One list is going to hold our animal images, and the other holds the musical notes for a You Got It tune. The logic from there is super straightforward. If button A gets pressed, show a random animal. If button B gets pressed, play that victory tune and clear the screen. That's it. That is our entire game plan. All right, we've got the blueprint. Now it's time for the really exciting part, bringing this thing to life. Let's translate this plan into actual micropython code that our little microbit can understand and run. We're going to tackle this in 5 clear, easy steps. First, we'll import what we need. Second and third, we'll set up our lists of images and sounds. And finally, steps 4 and 5, we'll code what happens when you press button A and button B. Let's do it. Okay, first things first. We have to tell our program what tools it's allowed to use. So we import random. That gives us the power to pick an animal at random. And then we import music so we can play our little celebration song. It's just like grabbing the right tools from your toolbox before you start building. Next up, we create those two lists, or arrays. The images array is where we store all the cool built-in animal pictures, like the duck, the tortoise, the giraffe, and the correct tune array holds our little sequence of musical notes. So boom, just like that, our program has all the content it needs. And now, for the heart of the game. This block of code is always running, just waiting. The second you press button A, this one line, display.show random.choice images, does all the heavy lifting. It tells the program, hey, go into that images list, pick one totally at random, and show it on the screen. That one little function is what makes the game fun and different every time. So what happens when your friend yells out the right answer? They hit button B. The code kicks in, plays our correct tune, then it waits for just half a second, that's the Sleep 500, and then it clears the display, making it all fresh and ready for the next round. So we've written the code. We're done, right? High fives all around? Well, not so fast. Writing the program is really only half the journey. Now comes the part where we make sure it actually works the way we think it does. It is time for testing. You know, a professional programmer never just writes code and hopes for the best. Nope. They create a test plan. It's a structured, organized way to check that every single part of your program does exactly what it's supposed to do. It helps you find those pesky bugs before anyone else does. And here's what a basic test plan looks like. It's pretty simple. You list an input, like a button pressed, and then you write down the expected outcome, which in this case is random image displayed. We test all the normal stuff, but we also got to test the weird stuff, the invalid inputs. Like, what if someone shakes the microbit? Well, according to our plan, nothing should happen. Testing this makes sure our code is solid. And if you do find a bug, this right here is your secret weapon. It's called a trace table. It's a super simple table where you basically play computer. You go through your code line by line and you write down what's happening to your variables. It's an incredibly powerful way to see your code's flow and find exactly where things are going wrong. Okay, our game works, it's been tested, it's bug-free. Now for the really fun part, making it even better. Because here's a little secret. A program is never really finished. There are always cool new features we can add. And this brings us to a huge concept in software development, iteration. Instead of trying to build this giant, perfect program all at once, you build a solid, simple foundation. Then, you add new features in small, manageable cycles. You build a little, test it, build a little more, test it again. So let's try our first iteration right now.
Let's add a brand new image. How about a question mark to show at the start of the game? We can actually design it ourselves on a simple 5x5 grid, where each number from 0 to 9 just tells an LED how bright it should be. Then, we can translate that visual grid directly into a string of numbers in our code. It's such a cool and visual way to make your own custom graphics. So, how do we get our awesome new question mark image into the game? You're not going to believe how simple this is. It's one line of code, images.append question mark. The append function just sticks our new creation right onto the end of our images list. That's it. Game upgraded.
How about one more feature? Let's add a little pressure, a little challenge. We can add a countdown timer. We can do this with what's called a for loop that just counts down from 3. Each time through the loop, it shows the number, and if it hits 0, it flashes an X to show that time's up. It's a perfect example of adding a new piece of logic in another small, simple, iterative step. So, if you take away one thing from all this, let it be this cycle. It all comes down to 4 steps. Plan, make your blueprint. Code, translate that plan. Test, make sure it actually works. And improve, add new features and iterations. This 4-step process, it's the foundation for pretty much every piece of software in the world.
You've now seen the entire process, from a simple idea all the way to a tested, working project that you can keep improving. You have the blueprint. Plan, code, test, improve. The only real question left is, what amazing thing are you going to build next?